Welcome to the deep dive. Today we're jumping straight into, well, something pretty mind-bending from quantum mechanics. Superposition.
That's the one.
Yeah.
It's foundational.
Right. So the idea is that tiny things, like electrons, can be in multiple states, multiple places, all at once.
Until we, measure them.
Exactly. Think of a normal coin toss. It lands heads or tails. Simple.
Okay.
But a quantum coin, before you look, it's sort of both heads and tails at the same time. That both at once state is superposition.
Both at once. Okay. Our mission today, then, is to try and unpack this, see what it really means.
Yep. Understand the basics and, touch on why it matters so much.
All right. So how do we even start thinking about something being two things at once? It feels wrong somehow.
It does challenge our everyday intuition. A famous way to illustrate this weirdness is Schrödinger's cat. It's a thought experiment, mind you.
Yes, the cat in the box. I've heard of it.
Right. So imagine a cat, a box, some poison triggered by a quantum event like a radioactive atom decaying.
If the atom decays, poison released cat. Yeah. If it doesn't decay, cat's fine. But the quantum atom itself is in superposition decayed and not decayed until measured.
So because the cat's fate is linked to that quantum state, the cat is also both alive and dead until we open the box.
Theoretically, yes. That's
Yeah.
the paradox. It's designed to show how bizarre it seems when you scale quantum rules up to, cats. It highlights the measurement problem.
The boundary between quantum and classical worlds.
Got it. So it's not literally an alive dead cat, but it points to the underlying quantum uncertainty.
Exactly. It's a conceptual tool.
Okay. Are there real experiments that, not just thought experiments, something that actually shows superposition happening? You mentioned the double-slit experiment before.
Oh, absolutely. The double slit is maybe the most fundamental demonstration. You fire particles, say electrons, one by one at a screen with two narrow slits in it.
Right.
If they were just tiny balls, you'd expect two lines on the detector screen behind the slits.
Makes sense. But what you actually get is an interference pattern, like waves would make. Bands of high and low intensity.
Interference. But with single particles, how?
Well, the only way to explain that pattern is if each single particle somehow went through both slits simultaneously, acting like a wave, and interfered with itself.
One particle, two paths at once. Still feels strange to say it.
It is. But here's the really weird part. What happens if you try to detect which slit the particle goes through? Put a little detector by the slits?
Yeah, what then?
The moment you measure, the interference pattern vanishes completely. You just get the two lines like you'd expect for simple particles.
So just looking or measuring forces the particle to choose a slit. It stops being in two places at once.
Precisely. The act of observation, of measurement, seems to collapse the superposition. It forces the quantum system into one definite state.
Wow. Okay, so observation changes the outcome. That's
This is
the
good.
fundamental. And this isn't just theoretical weirdness, right? You hear about quantum computing using this stuff.
Absolutely. This is where superposition becomes incredibly powerful. You know how normal computers use bits, either 0 or 1.
On or off.
Quantum computers use qubits. And thanks to superposition, a qubit can be a 0, a 1, or crucially, a combination of both 0 and 1 at the same time.
Like our quantum coin being heads and tails, so it holds more information.
Sort of, but it's more about processing. Because they can explore many possibilities simultaneously, all the combinations of zeros and ones represented by the superposition, they can tackle certain problems exponentially faster than classical computers.
Like what kind of problems?
Things like complex simulations, maybe discovering new materials, breaking certain types of encryption, optimizing huge systems, problems where you need to check a vast number of possibilities.
That sounds revolutionary, actually.
It has that potential, yes. Still early days in many ways, but the principle is sound.
Okay, stepping back a bit. This whole idea, superposition, reality being sort of fuzzy until we look, that really shakes up our basic picture of the world, doesn't it?
It absolutely does. Philosophically, it's huge. Is reality inherently uncertain? Does observation somehow create the definite state we see? Does consciousness play a role? Big questions.
Yeah, no easy answers there, I imagine.
Not at all. These are things physicists and philosophers still debate.
So let's recap. The main thing is superposition is real. It's been tested. Particles can be in multiple states at once.
Definitely. It's a cornerstone of quantum mechanics, proven experimentally.
And it's not just weird, it has these massive implications for technology, like quantum computing.
Crucial implications, yes. It challenges our intuition, but unlocks new possibilities.
So a final thought for everyone listening. Maybe think about this. How does simply paying attention to something, really observing it, change it in your own life? Maybe not collapsing a quantum state, of course, but, How becoming aware of a situation, a feeling, a problem, how that active observation itself can be the first step towards changing its nature. Something to ponder from this quantum journey. Thanks for tuning in.